right, good morning, class. Are y'all with me this morning?
Yes, good morning.
Good morning. All right, let's get started. Let's check out this exam number 7. Um, a lot of y'all didn't turn in anything, so uh, make sure you at least try, I usually give you half credit if you at least try, so we shouldn't be getting any zeros here. All right, so on number 1, they say if you travel 65 miles an hour, how many feet can you travel in 22 minutes? So what they're asking us to do is what we have to do is we have to convert 22 minutes into feet. That's what they're asking us to do. And they tell us that 65 miles is equivalent to 1 hour. So we do our 22 minutes and we got to get rid of minutes. We want to end up with feet. Now we see that 65 miles is the same as an hour, 65 miles an hour. That's what they tell us. Okay. So what we can do here is we want the time to go away. So we can take these the 1 hour and change that into 60 minutes, right? So the minutes will go away and we're left with a length here. It's in miles, but we want it to be in feet. So now we need to get rid of the miles in favor of feet. And if we look down here, it's 5,280 feet make a mile. So 1 mile is 5,000. Let me give myself a little more room here. 5,280 feet make a mile. So notice we've taken minutes and we've converted it to feet. Okay, so now all we have to do is multiply this out. 22 times 65 times 5280 divided by 60, 125,840 feet. And does that make a little more sense now? I know it's a strange way of looking at things, turning minutes into feet, using the fact that 65 miles is the same as an hour. Any questions on this one? All right. Number 2 is similar. So a child requires 4.5 milliliter dose of medicine each day. So what they're saying here is 4.5 milliliters is the same as a day. How many days would a cup of this medicine last? So what we are doing is we're taking a cup and we're converting it to days using the fact that 4.5 milliliters is the same as a day. Right? So if you just think about it, it's like, well, if you have 4.5 milliliters each day, how many days would a cup last? So we just need to convert this to cups, right? Is that if that was a tenth of a cup and you have 1 cup, then it would last 10 days, right? If we're going to lay it out the way we did problem number 1, let's see, we have a cup and we want to convert it to days. So we have 1 cup. Now we're going to convert this to days using the fact that 4.5 milliliters is the same as a day. So 4.5 milliliters is the same as a day. That's what they say right there. See, this is a volume, that's a volume. All we have to do is convert the milliliters to cups and we'll be left with days. So if we look down here, nowhere does it, well, it has, the closest we have is milliliters to fluid ounces, and then fluid ounces to cups. So if we say, okay, I want to get rid of milliliters, we get fluid ounces. There's 29.6 milliliters in a fluid ounce. Now we'll get rid of the fluid ounces in favor of cups, right? There's 8 fluid ounces per cup. So the cups go away and we're simply left with days. Now follow that? If you look right here, we're turning cups into days. All we have to do is find out how many milliliters make a cup, basically. Like I said up here, 4.5 milliliters per day. How many cups? Well, if this is 1/10 of a cup, then it would last 10 days. But it's not 1/10, it's something else. And what we're figuring out is right here. How many cups is 4.5 milliliters? That's what we did right here. So our units go away. We're left with days. So we just have to do our calculation here. 29.6 times 8 divided by 4.5 is 52.6 days. Some of y'all use a different conversion. I forget what y'all used. Instead of this, you used something. It was close enough though. You got like 55 or something. You just didn't use the conversion in this chart. You used a different approximation, which was fine. Your answer was fairly close. Any questions about these two?
No, sir.
Okay. Let's do a quiz. What's this? Quiz 8? This is 7. Yeah. Quiz number 8. Okay, I'm gonna pick these out. Since we did this. Yeah, from the homework on 53, I'll pick out some homework problems. So we'll solve the equations. Let's do this one. Remember, when you get your answer, you can always plug in whatever you got for X, plug it into the equation to check your work. Okay. See if you got it right. Plus, the answers to these homework problems are in the back of the textbook. There's an answer key back there. Let's do this one. Okay, it's 10:40. Let's take 15 minutes. So we'll come back at 10:55. We'll get you in your breakout groups. All right, class, welcome back. Let's look at number 1 here. All right, so we have X's in 2 different locations. We need to get those X's together. The first thing I did do is distribute this minus sign through here. So if we do that, we have a negative 3x and a negative 2, which is a plus 2. So if we now combine these, we get a 2x plus 2. All right, so now we just got to get to this x. So let's subtract 2 from both sides. So 14 minus 2 is 12 equals 2x. Now let's divide both sides by a 2. And if x is 12 over 2 is 6. Right? The biggest mistake I see most people probably making is not distributing the minus here. A negative 2 is a positive 2. Any questions about this one? All right, let's look at number 2 here. So here's our x, and we have another x over here. First thing I'd do is get rid of the fractions. I'd multiply both sides by 6. So now I'd have a negative 24x equals a 5 times a 1 minus x. Okay, the next thing I do is I distribute this 5 so I can get rid of these parentheses here. So 5 times 1 is 5. 5 times a negative x is a negative 5x. And now we have x's in 2 different locations. I'd resolve that by adding 5x to both sides. So that goes away. And then we have negative 24x plus 5x is negative 19x equals 5. And now to get to the x, divide both sides by negative 19. We have x equals a negative 5 over 19. Any questions about that one? These can be difficult if you haven't seen them before. It's just going to take a lot of practice.
Is it okay if I didn't do it like you did, but I still got the right answer?
Yeah, you can do it a whole different multitude of ways. This is just one way of approaching it. All right, we can let's check our work though. All right, let's make sure we got the right answer. Let's get number 1 here and let's check our work. Check. All right, our left hand side is 14, right? So let's check out our right hand side. Right hand side, if we replace x with 6, let's see, we have 5 times 6 is 30 minus 6 times 3 is an 18. 30 minus 16, which is 14. And that's the other side of the equation. That's our left-hand side. Let's check them out. So number 2 here. Let's move this back up here. So let's check our work. All right, our left-hand side. All right, we have, let's see what our left-hand side is equal. Our left-hand side, -4 times a -5/19. That's a positive 20/19. All right, that's the left-hand side. So let's see what the right-hand side is. Right-hand side, 5 times a 1 minus a -5/19 all over 6. So 1 is 19/19. Minus minus means plus. So 19 and 5 is 24/19. Okay, so let's see here. It's the same as 5/6 times a 24/19. Let's see, how can we reduce this thing? 24 is 8 times 3, right? 8 times 3, yeah. And 8 is 2 times 2 times 2. So that's our 24. 6 is 3 times 2. So 5 times 2 is 10 times 2 is 20. This is 20/19, which is our left-hand side. So it is indeed correct. All right, any questions? All right. Move on. All right, we're on page 55. I'm going to start graphing. So here we have our X and our Y axis, and our quadrants are labeled 1, 2, 3, 4. Notice they go counterclockwise. Okay, so let's see, if you're given a coordinate, say 1, 2, all right, the first coordinate is left or right. The second coordinate is up or down. So if you have a 1, 2, that means you go to the right 1 and you go up 2. So that point right there is 1, 2. So the coordinate 1, 2 is in quadrant 1. Okay. So if an X coordinate is positive, in which quadrants? Anywhere over here. So that's 1 and 4, quadrants 1 and quadrants 4, because you're going to the right, that's where your X coordinate is positive. If your X is negative, say like -3, 2. Well, that says go to the left 1, 2, 3, and then go up 1, 2. So that's a -3, 2. So if you're going to the left, you're either in quadrant 2 or 3, and you only go to the left if your X coordinate is negative. All right, part B, Y coordinates. The Y, the second one, is how far you go up or down. If it's positive, you go up. So if you're going up, you're either in quadrant 1 or 2. If your y coordinate is negative, then you're going down, which means you're in quadrants 3 or 4. Okay. It's like playing Battleship. All right, let's plot the following points. So 2, 5, we go to the right, 1, 2, and then we go up 5, 1, 2, 3, 4, 5. So there's 2, 5. -2, -5, we go to the left 2, and we go down 5, 1, 2, 3, 4, 5. So right there is a -2, -5. 7, 3, we go to the right 7, and then we go down 3, 1, 2, 3. So that is 7, -3. -4, 6, we go to the left 4, and we go up 6. -4, 6. Easy so far, right? First number is left and right. Second number is up and down. Do some more plotting. All right, 0, 5. So our x coordinate is 0, so we don't go left or right at all. We just go up 5. So 1, 2, 3, 4, 5. So that's 0, 5. We didn't go left or right. We just went up 5. 0, -5. We don't go left or right, but we go down 5. So there's 0, -5. 0, -1. We don't go left or right, we just go down 1. And 0, 9. We don't go left or right, we go up 9, 0, 9. So all of these have zeros in the x for the x coordinate. So they all lie on the y-axis. All right, these points are called y-intercepts. They're called that because they're lying on the y-axis. So y-intercepts. Here soon we'll be talking about lines. We'll be like, that's its y-intercept, the point where it crosses the y-axis. But we got to get points down before we go to lines. All right. X-axis, y-axis. Plot 2, 0. All right, we go to the right 2 and go up and down 0. So that's 2, 0. -2, 0. Go to the left 2. Don't go up or down. -7, 0. Go to the left 7. Don't go up or down. And 6, 0. Go to the right 6. Don't go up or down. So since all of these lie on the x-axis, they are called x-intercepts. What do they have in common? Their y value is all 0. Okay. Solve the following equations so that they're in y equals mx plus b form. So notice there's two variables here, an x and a y. It's a relationship between two variables. we can manipulate these equations and put them in this form. Y equals stuff with X in it. The reason why we want to do that is because it'll allow us to see what the graph looks like. Okay, which we'll understand why shortly. But for now, let's just work on getting it into this form. So on number 5 here, if we divide everything by 2, y equals 3/2 x plus 4. Okay. So we put it into this form here. So m is 3/2. It's the number we're multiplying the x by. And our b is 4. Okay, why do we want to know this? Well, if we think of the x as input and the y as output, all right, think of x as input, y as output. If x is 0, you plug a 0 in here, then y would be 4, right? So if we were going to graph this thing, when you had equations that just had an x in it, your solutions were just like x equals 1 or x equals 7. Because there's 2 variables, the solutions to this, there's an infinite number of them. You know, when x is 0, y is 4. So a solution to this equation is 0, 4. Right? There's 2 numbers that go to have a solution to this equation. But there's an infinite number of them, right? If x is 1, then y is 3/2 plus 4, right? If 4 would be 8/2, that'd be 11/2. So another solution to this equation is 1 11/2. There's an infinite number of them, okay? And what we can do is we can graph all the solutions. If you take all the solutions to this equation and graph them, you're going to end up with a line. So here's 2 points, 2 solutions. X equals 0, y equals 4. So we go 1, 2, 3, 4. That point is one of the solutions to this equation. This one right here gives us another one. This m will tell us the slope. So it's rise over run. It tells us, we'll go into this in more detail here shortly. Rise over run. It tells us that if we go up 3 and to the right 2, 1, 2, 3, 1, 2. So if we went up 3, it would be at 7, and to the right 2 from 0 to 2. All right. The slope, it tells us the slope of the line for all the solutions. If we go, was it up 3 and to the right 2, you're going to end up with another point on the line. And this line is the set of all solutions to this equation. Okay. So to keep that in mind, we're going to go over this in detail. I just want to do it real quick so you get the idea of why we're taking these and putting them into mx plus b form. So we want this to look like this. So to do that, we'll divide everything by a -3. So y 3 over a -3 is a negative x. -9 over -3 is a positive 3. So here our m, the thing you're multiplying x by, is a -1 because it's negative x. And our b here is 3. It's the thing you're adding to the x component. So we'll go to 7 here. All right. We want to get the y by itself. Let's subtract 2x from both sides. It gives us a 3y equals negative 2x plus 15. I'm going to put the x first, so it looks more like that. Now I'll divide everything by 3. So we got a y equals negative 2/3 x. 15 over 3 is 5. So our m here is negative 2/3, and our b is 5. And number 8, let's subtract 3x from both sides. That gives us negative 3y equals negative 3x plus 9. Now divide everything by negative 3. We have y equals negative 3 over negative 3 is just 1. So we get x. 9 over negative 3 is negative 3. So notice here our m, there's nothing in front of the x, right? That means our m is 1. There is a 1 there. We just don't ever write it. Okay? So that's a tricky one. The m is a number you don't see. It's number 1. This is 1x. And our b here is negative 3. All right. Here we just need to multiply everything by a negative 1. So we get y equals negative 2x minus 1. So our m is a negative 2 and our b is negative 1. All right, let's subtract 5x from both sides. So we have a 15y equals negative 5x minus 15. Now divide everything by 15. We get y equals negative 5 over 15 is what? Negative 1/3. 5 over 15? Yeah, the minus. 15 over 15 is 1. So m here is a negative 1/3 and b is a negative 1. So we're going to do a lot of these, okay? All right, getting y by itself, let's subtract 6x from both sides. We have a negative 3y equals negative 6x plus 18. Divide everything by a negative 3. So we get y equals negative 6 over negative 3 is a positive 2. 18 over negative 3 is a negative 6. So m here is 2 and b is a negative 6. All right, let's see. To get our y by itself, let's add subtract 1/2 x from both sides. That gives us a negative 2/3 y equals negative 1/2 x plus 4. So now to get the y by itself, let's multiply both sides by a negative 3/2. So the 3's go away, the 2's go away, and the minuses go away. Gives us y equals. So we have a negative 3/2 times a negative 1/2 is a positive 3/4. And a negative 3/2 times a positive 4. That's negative 12 over 2, which is 6, right? 12 over 2 is 6. So y equals 3/4 x minus 6. So our m here is 3/4. And our b is a -6. Number 13. All right, let's subtract a half an x from both sides again. So we get a 2y equals -1/2 x plus 6. Now we can divide everything by 2. Y equals a half divided by 2 is a fourth. 6/2 is 3. So our m is -1/4. Our b is 3. Questions so far?
No, sir.
All right. Okay, this guy, let's multiply both sides by 2. That way we get an x plus y equals -6. Now we'll subtract x from both sides. So we get a y equals -x minus 6. So our m here is a -1, because that's what we're multiplying the x by. And b is a -6. All right, stick with me here. We'll take a break in 7 minutes. All right, this guy, we're trying to get the y by itself. Let's subtract 1/3 x from both sides. It gives us a -2y equals -1/3 x plus a 2/3. And now let's divide everything by a -2. So we get y equals a -1/3 divided by a -2 is a +1/6. And a 2/3 divided by a -2 is a -2/6, right? 3 times 2 is 6, which is the same thing as a 1/3. So our m here is 1/6, and our b is a -1/3. All right, 16. All right, subtract a half an x. We got a 3/4 y equals -1/2 x plus 3. I'll multiply both sides by a 4/3. So we get a y equals -1/2 times 4/3 is 4/3 times 2 is 6. And plus 4 times, well, those would cancel here. So 4. 4 times 3 is 12. Divided by 3 is 4. I lost my x here. So 4/6 is 2/3. So m here is a -2/3 and b is a +4. Okay, some more equations here. Evaluate a minus c over b minus d. The reason why we're doing this, because I told you m, which was the slope, which was the rise over the run. All right, let's say you have 2 points. I'll call them x1, y1, and x2, y2. All right, there's just two coordinates. All right, so here's x1. So those are the 2 points, right? The rise over the run. Okay, the rise is, well, from here to here, right? This would be the rise. Well, what would the rise be? All right. It's the difference. We go from here to here versus here to here. It's the difference between the two. The rise would be a y2 minus y1. It's the difference in the y values. And the run, right? Again, here's our 2 points. We're looking at this length right here. All right, that's going to be the difference in the x coordinates. That's what m is, okay, for any 2 points on the line. That's why we're going to do fractions like this, okay, which we'll talk more about this later. Okay, just giving you a heads up as to why we're doing a whole bunch of these problems. So a minus c over b minus d. A is 10, c is 4, b is 7, d is 5. So 10 minus 4 is 6, 7 minus 5 is 2, 6 over 2 is 3. A minus c over b minus d. So the big mistake people are going to make here is with this minus sign. All right, a is 5. We put the minus sign in. C is -3. We're subtracting a negative, okay? So b here is a -7. We put our minus, and d is 9. So 5 minus -3 is 8. -7 minus 9 is a -16. So this gives us a -1/2. Now, what if we have a bunch of crappy fractions? A minus c over b minus d. A is a 1/2, put the minus. C is 5/2. B is a 1/3 minus. D is a -5/6. So on the top, it's easy because we have a common denominator. It's 2. So this is going to be a 1 minus 5 over 2. So 1 minus 5 is a -4. Down here, we don't have a common denominator, but we can rewrite 1/3 as a 2/6. We have a minus minus, which is plus. So a -4/2 is just -2 on the bottom. Since we have common denominator of 6 now, we just add 5 and 2 is 7/6. Dividing by a fraction is the same as multiplying by its reciprocal. We have a -12/7. Okay. Let's take a 15-minute break, and we'll come back at 11:45 so we can wake up. I'll see y'all at 11:45, folks. All right, class, and we are back. Let's go to number 20. We need a minus c over b minus d. A is -5/7. We have a minus sign. C is 2/3. B is 2. Minus sign. D is 2/3. All right, so let's turn this thing into a single fraction over a single fraction. What we need to do is get a common denominator here. So let's multiply this -5/7 by a 3/3, and this 2/3, and just 7/7. So notice both fractions now have a 21 on the bottom. So we'll be able to combine those. Over here, let's multiply this 2 by a 3/3. Now down here we have common denominator of a 3. So on the top we have -15/21 minus 14/21. Down here we have a 6/3 minus 2/3. So on top we have a negative and a negative. So if we put those together, we have negative 29/21. 6 minus 2 is 4. So instead of dividing by this fraction, we're going to multiply by its reciprocal. And let's see, what is 29 times 3? 87. Actually, let's not do that yet. Let's simplify this. 21 is 7 times 3. So those 3's can go away. So we got a negative 29 over 7 times 4 is 28. Any questions? It's all just fractions here. Fractions and fractions and fractions. We'll be good at fractions by the time we're done with this. All right. A minus C over B minus D. A is 8, minus sign C is 8. B is 3, minus sign D is -2. That is 0. 3 minus -2 is 5. 0 divided by 5 is 0. All right, 5 goes into 0 times. Two here. A minus C, B minus D. A is -7, minus C is a -1. B is 4, and minus D is 4. So we have a -7 plus 1 is a -6 over 0. What happens when you divide by 0, folks? This is undefined. You cannot divide by 0. Okay. Why can you not divide by 0? Let's say you took 6 and divided it by 0.000001. This is really big, right? If I made this number smaller, that's even bigger, right? So the closer this number on the bottom gets to 0, the bigger this number gets. Okay. So if I plugged in something that's really close to 0, I'll call it 0 plus. It's something really close to 0 but positive. This thing goes to infinity. 6 divided by something teeny tiny is something really huge and positive. But what if I plugged in -0.000001? This is something really big, but negative, right? If I put in a number even smaller, but still negative, this is even bigger, but negative. So if I plugged in, call it 0 minus, something really close to 0, but negative, this number gets bigger and bigger, but it goes to a negative infinity. So 6 over 0, it's both positive and negative infinity. And being equal to both of those you don't have any numbers any further apart than positive and negative infinity. Okay, so this is both positive and negative infinity, which doesn't make any sense. So that's why you cannot divide by 0. All right, no zeros on the bottom. Not until you get to calculus. That's what calculus is all about, is dividing by 0. 23. When is having a 0 in a fraction defined? It's okay if 0 is on top, like this one. 5 goes into 0 exactly 0 times. It's undefined when 0 is on the bottom. Discuss, well, 1 over 0 is both positive and negative infinity. All right, questions about that?
No, sir.
All right. All right, getting closer to linear graphs here. All right, a linear equation in 2 variables. Those are the ones that we're just looking at when there's an x and a y. The a, b's, and c's are just real numbers. So 2x plus 3y equals 4. That's an example of a linear equation in 2 variables. 7x minus 2y equals 0. That's a linear equation in 2 variables. All right. This is an example of all possible linear equations in 2 variables. They all can take on this form. So let's look at these. Which of these represent linear equation in 2 variables? That one has an x and a y. This one doesn't. This one doesn't. This one has an x squared in it. Yeah, there's an x and a y, but that squared means it's not linear. So no. All right. Basically, this guy, if you graph that, the solutions to that equation, the solutions will be a line, a straight line. That's why I call it a linear equation. Any point on this line, if you take the x and plug it in and the corresponding y and plug it in, the left-hand side will equal the right-hand side. This guy over here has an x squared. Its solutions are going to look like this. It's going to be a curve. And that's why it's not a line. It's a curved line, so it wouldn't be considered linear. So example. So for this linear equation, x plus 2y equals 8, this point 6, 1 is a solution, because if you plug the 6 in for x and you plug the 1 in for y, 6 plus 2 is 8. The left-hand side equals the right-hand side. So remember the old equations where there was just an x, the solution would be like x equals 1 or x equals 7. But equations with 2 variables, the solutions look like this, 2 coordinates. There's an x and a y. And because of that, there's an infinite number of solutions. This is just one of them that works, 6, 1. Okay. What if I plugged in a 0 for x? Then I would have 0 plus 2y equals 8. I divide both sides by 2, and I would have a y equals 4. So 0, 4 is also a solution, right? Because if I plug in 0 for x, y is going to equal 4. Okay, so again, there's an infinite number of solutions and they all look like this, coordinate pairs. And if you take all of them and graph them all, you're going to end up with a line. In this case, I can show you what they are. 1, 2, 3, 4, 5, 6, up 1. That's 1 point. That's a solution, right? And 0, 4, if I go to the right and left 0 and go up 1, 2, 3, 4, that's another solution. Because this is a linear equation, I know all the solutions are going to fall on this line that goes through those 2 points. So 2 points define a line. So this is a solution, this is a solution, this is a solution. If you take the x and the y for that point and plug it in here, the left-hand side will equal the right-hand side. So show that -2, 5 is also a solution for the same equation. Well, the left-hand side, all right, I'll put in a -2 for an x and a 5 for a y. I got -2 plus 10, which is 8, which is equal to the right-hand side. So -2, 5 is a solution. So I went back 1, 2, and up 1, 2, 3, 1, 2, 3, 4, 5. Right there. That's that point. It's on that line. All right, can we find a, here we go, they're graphing it for us finally. Can you find another solution? Basically plug in any number you want for x and solve for y. We just did one of them. We did the easy one. We let x equal 0. If x equals 0, then 2y equals 8, which means that y is 4. So 0, 4 is a solution. Let's say if x equals 2, plug a 2 in, then we get a 2 plus 2y equals 8, or 2y equals 6, or a y equals 3. So 2, 3 is also a solution. Look, 1, 2, up 1, 2, 3, boom, 2, 3, that's also a solution. 0, 4 was a solution. Pick any point. What's this one? This is what I go up, I go back 6 and then I go up 7. I can look at the graph and see that's a solution. Well, let's check it. Left-hand side, I put a -6 in for x and a 7 for the y. I got -6 plus 14. What do you know? That's 8, the right-hand side. So these graphs are visual representations for solutions to equations. Okay. Here's our x's, here's our y's. We can look at this and visually see the solutions to that equation are the points on this line. Any point on the line is a solution to that equation. The first coordinate is your x, the second coordinate is your y. Any other coordinate are not solutions. If you take the x and the y for this point and plug them in, the left-hand side is not going to equal the right-hand side. Does this make sense? It's what graphing is. It's a visual representation. So those of y'all that like to work with pictures instead of numbers, this is your friend. All right, intercepts. The x-intercept of a line is the point at which its graph crosses the x-axis. So up here, here's your x-axis, right? This guy. So this point right here, 8, 0, that's the x-intercept. And the y, here's your y-axis. This point right here, 0, 4, that's your y-intercept. That's the point where it crosses the y-axis. So those are important. Those are the easy ones, you know, because you can plug in 0 for one variable. It's easy to find the other. So if we're looking at this equation, we did it twice. We said, what if x is 0? Then it's really easy to find out what the y is. Likewise, you could say, what if y is 0? Then, boom, you have x equals 8. Those two are easy to find. And remember, 2 points make a line. So if you get those two, you just draw a line through it. Boom, there's all the rest of your solutions. So that's why we like the x and y intercepts. They're special in that sense. They're the easy ones to get. Okay, so find the x and y intercepts. Well, here's one. This is 0, 8. That's our y intercept. This dude right here, this is a negative 5, 0. That is our x intercept. Look at this dude. This goes through the origin. This is 0, 0. All right. It is both the x-intercept and the y-intercept, because that's the only point that's on both the x-axis and the y-axis. So it's called the origin. It goes through both. This guy here. What's this one? This is a over 5 up 0. That's on our x-axis. That's our x-intercept. This point here looks like a 0, negative 3.5. That's our y-intercept. Questions about intercepts? Find the x and y intercepts for each of the following lines. All right, for number 1, if x is 0, then y is, plug a 0 in right here, then y is just 9, right? So 0, 9. All right, where is that? That's go to the right or left, none, go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, 0, 9. This is our y-intercept. To find the x-intercept, let y be 0. If y is 0, then we have 0 equals negative 2x plus 9. Or negative 9 equals negative 2x. Or x equals 9 over 2 is 4.5. So 4.5 comma 0 is our x-intercept. Where is that at? We're going up, going to the right, 1, 2, 3, 4.5, going up, down, none. That's 4.50. That's our other one. Here's our line. It gives us all our solutions. So on number 2 here, if x is 0, then y, put a 0 in, we get y equals 6. Boom. So 0, 6. Where's this? We're going to the right, none. We go up, 1, 2, 3, 4, 5, 6. Boom. That's 0, 6. This is our y-intercept. Right? So when x is 0, that's your y-intercept. If y is 0, then we have 0 equals 6 plus x. Plugging in a 0 there. which tells us that x is a -6. So -6, 0, which is 1, 2, 3, 4, 5, 6. This is -6, 0. This is our x-intercept. We have 2 points here. This line gives us all the solutions to this equation. Okay. We like to put things in this form, this y equals mx plus b. All right. So what we'll do is we'll think of y, we'll call it f of x, a function of x, where x is your input, y is your output, right? This is a function of x. Y is a function of x. Plug in a number for x, find out what your y is. All right. So this would be your x. This is your f of x or y. When I say f of x, I'm not saying f times x. That's a function of x. So like this guy here. Notice it's not in y equals mx plus b form. We don't have to put it in that form, but we could. All right. But just to find the intercepts, if x equals 0, then 12y equals 6, which means y equals a half. So therefore, 0, 1/2. All right, where is this? Go to the right, none, go up, a half. All right, this is 0, 1/2. This is our y intercept. All right, now if y is 0, plug in a 0 right there, we get a -2x equals 6, which means x is a -3. So -3, 0. We go back 1, 2, 3, go up none. This is -3, 0. This is our x-intercept. Since we know 2 points, let's try that again. That line right there represents all the solutions to this equation. So there's lots of software that'll graph these, okay? You can probably just type it into a Google, type graph 8x plus 5y equals 17, and it'll produce your graph for you. So find the intercepts. If x equals 0, then 5y is 17. So therefore y equals 17 over 5, which is what, 3 2/5. So therefore 0 and 17/5 is our y-intercept. Go to the right and left, none, go up 1, 2, 3 and a little bit. This is 0, 17/5. So that's our y-intercept. To get our x-intercept, we let y be 0. If y is 0, boom, we have 8x equals 17. So therefore, x is 17 over 8, which is the same as 2 1/8. So 0, 17/8 is our x-intercept. Sorry, I did this backwards. X is 17/8 and y is 0. That's our x-intercept. So we go to the left, 17/8, which is 2 and a little bit. Don't go up or down. So I'm sorry, it's not left. It's a positive. So I go to the right, 1, 2 and a little bit. So that's our our x-intercept. So this line right here gives us all the solutions to this equation. All right, sketch the graph of a line that does not have an x-intercept. All right. Well, this is our x-axis and here is our y-axis. If it does not cross the x-axis, then how about that? Make it orange. All right. Notice it's parallel to the x-axis, right? Now, if it does not have a y-intercept, it means it can't cross the y-axis. So how about that? I mean, if it doesn't cross it, it has to be parallel to it. So let's look at this guy here. Five y over 2 equals 10. There is no x anywhere, is it? Let's multiply both sides by 2/5. That gives us y equals 10 over 5, y equals 4. So 5y over 2 equals 10 is the same thing as y equals 4. To graph that, there's an x, there's a y. We want all the points where y is 4. 1, 2, 3, 4. All right. This point is 0, 4. 1, 2, 3. This point here is 3, 4. 1, 2. This point here is a -2, 4. Okay. So to graph this, it's going to be this line that's parallel to the x-axis. It's a straight line. Y equals 4. It means all the points where y equals 4. It doesn't say anything about x. X can be anything you want. Okay. So this is like those equations we used to solve where there was just one variable. Well, if you think about it in a system of two variables where one variable simply isn't mentioned, you're still looking at a line. So here's one where only x shows up and no y's. Well, if we divide both sides by 8, we're looking at x equals -2. So this is our x-axis and this is our y-axis. Make this blue. Make this orange. All right, x equals -2, 1, 2. That line right there is the solution to this equation. That point is -2, 0. We could have 2, 3, 4. This is a -2, 4. 1, 2, 3. This is a -2, 3. Notice every point on that line has an x coordinate of -2. Okay. So yeah, this is an equation with one variable, x equals -2. But if you think about it as an equation with two variables where one variable simply isn't mentioned, then your solution, instead of just x equals -2, can be thought of as this line where all the points have an x coordinate of -2. All right, write an equation of a line with y-intercept 0, 5. Well, let's see. X y. Where is 0, 5? Go to the right, none. Go up 1, 2, 3, 4, 5. So if we want an equation that has that y-intercept, how about y equals 5? There you go. Y equals 5. That's the line y equals 5. Every single point here, say 1, 2, 3, 4, 5, 6, 7. This would be a 7, 5. 1, 2, this would be a -2, 5. That line, every single point on that line, the y coordinate is 5. And this is the equation for it, y equals 5. Let's see. I guess we have what, 13 minutes. Let's go ahead and do our exam number 8. And this is a good one. 11. Let's do number 1 here. Solve for x. And number 2. This one will work. All right, there you are, folks. Get your answers in before the end of the day, and I will see y'all on, what is today, Monday? I'll see y'all on Wednesday.
Have a good day.